Hello everyone and welcome back to the course, Identifying Web Attacks Through Logs. In the last video, we talked about brute force attacks. This is Module 2, Episode 4, and in this video, we'll start talking about injection attacks. The first injection attack will be SQL injections. So to start, let's check the video objectives. First, a brief introduction of injection attacks. After that, we'll review SQL attacks, SQL injection attacks, followed by performing web analysis to identify SQL injection attacks. Injection attacks are related to OWASP TOC A1. In 2007, it was a top vulnerability. Injections are so common that OWASP classified it as a top vulnerability in 2010 and 2013 as well. Here's the definition from OWASP. Injection attacks occur when the central request contains some unexpected data, and this data is executed by the web server. Remember, the web server doesn't care about the request, and if the request is malicious, the web server will still process it. SQL injection is one type of injection attack. There are many other injection attacks. Here's a list of some of them: SQL injection, file injection, and others. But in this video, we'll focus on SQL injection. Because of the multi-layer web application architecture, the client should only access the web server. In an SQL injection attack, the client sends the request to the web server, but the web server will send the request to the database, and the database will process it. Depending on the request, the database can execute unexpected commands. And these commands that come back to the database server can impact the web application. SQL injection is considered a critical vulnerability. It directly affects the database server. Here we have a comic strip joke about SQL injection. Here, the impact was losing all the database of the students. This could be fun, but if this happens in a production environment, the consequences could be tragic. So let's talk about SQL injection. Here are some considerations to keep in mind with SQL injection attacks. It needs to use SQL, or the database won't process it. Usually, it's caused by incorrect user input validation, like allowing special characters in the form. It's an old attack. We've known about it since 1998. It's also more common on legacy applications. It's a server-side attack, and it has some types, like blind, classic, union-based, and error-based. In our lab, there's a web application vulnerable to SQL injection attacks. It's simple. It's just a form with only one text box to put the user ID. If we try the number 1, we have the admin user information. Here you have the request made to the web server. It's a simple request. You can see that the ID has the number 1, the admin ID. The information about the admin is shown, but if we don't say a number, what happens? This is an example of a malicious request. To summarize this user ID request, you say to the database, I want all the user IDs that are equal to A or 1 equals 1. 1 equals 1 is always true, so the database will send all the usernames. This is the result of the request, all usernames and information about the usernames. Now, maybe you're thinking, can the web server logs identify SQL injection attacks? Let's analyze both request web server logs. The first is the ID number 1 request, and the second log line is a malicious request. Notice that whatever you put in the user ID, you'll be sent to the web server and to the database server. Another important thing is that this request is encoded. After decoding, we'll see the same request that we used. Because of the SQL, it's easy to see encoded requests during SQL injection attacks. It's important to notice that the web server answered both requests, and this includes the malicious request. Depending on your web application, this would mean that your application is vulnerable to the SQL injection. Now, let's analyze these 3 log lines. These lines were generated by the SQL map tool. SQL map is a well-known tool used to perform vulnerability scans or to perform SQL injection attacks. Many of the vulnerability scans can execute SQL injections. So during the vulnerability scans, it's possible to see SQL injections, and depending on the policy of your company, you can classify the attack as a vulnerability scan or as an SQL injection attack. Again, the user agent can help you in identifying the attack. Analyzing the logs, you should see SQL-related words or comments like and, select, case, when, union, and others. Always check the response of the web server. On the previous slide, the answer was 200, so the web server answered the request. In the 3 log lines, we have 302 to the right direction. Sometimes you need to correlate more than one log line to understand the entire attack. For further information, here are the same 3 log lines, but now decoded. If you don't know about SQL comments, you can ask your database admins if these comments are malicious or could impact the database server. In the next slide, we'll analyze 2 more log lines. Here they are. Again, we use the SQL map, but we change the user agent. You can notice encoded requests and many SQL words. In the second log line, you have the where and the exec comments. Taking a better look, you can find more comments in words but related to Linux operational system, like cat and fpassword, and in this slide, the decoded request. One more question. What about post requests? To analyze post requests, you need more logs from other sources. A good source is the back capture. For example, this is a web server log for a post request. The web server log only shows the post request to the login page. There's no information about the request, but in the package capture, you see the HTTP request and all the form data that was sent. Notice that this request is similar to our examples, although it's not that easy to get a package capture. But if it's possible, you should try and ask for them. To summarize, how do you identify the SQL injection? First, SQL commands like from, select, where, and others. Look for encoded requests. Also, remember to look for user agents and the operational system related comments or words. Now, let's do some post-assessment questions to practice. In the first question, analyze the log below and identify the web application attack. After, choose the option with the correct attack. You can pause the video if you want. It's easy to see that this log is big and contains a lot of encoding. In addition, it's easy to find the SQL words like select, and, count, and others. So this is an SQL injection attack. For further information, here is the decoded request showing the SQL request. Now, check this affirmation. Web server logs will show all information about user actions. Is this affirmation true or false? This affirmation is false. If the web application uses post, or if the web server login configuration is wrong, maybe the log can't help you. If this happens, you need to ask for the right configuration, or for other logs. Video summary. In this video, we talked about the type of injection attacks, SQL injection attacks, some directions to identify SQL injection attacks on the web server logs like SQL comments, encoded requests, user agent, and operational system comments. After, we showed the difference between post and get requests, showing an example of a package capture with an SQL injection attack. In the next video, we'll keep talking about injection attacks. We'll discuss file injection, or file inclusion, and the 2 types of inclusion, local and remote file inclusion.